Yo, what's up, everybody? Um, let's get started. So, it's still water on the menu, and yesterday's improvement was quite nice. So, let me just visualize it again before we continue. Right about, let's see, yeah, let's go there. So this is the visuals we had of the water previously. There's a little bit of a jagged edges going on, especially when the water is moving downwards or upwards, and you have these intersections between ground and water that makes these jagged edges. What's up, Cooler SK? And yesterday we fixed it by always pretty much just moving the... So the cause of this is the topology, or that's one of the reasons for it, because the topology is pretty much working against us in this direction. So on this side and this side, while we get nice edges on this side. So in the case when we have the topology working against us like this, we just check if this point is without water and it has one neighbor, or its diagonal neighbor, one of them has water. If so, we interpolate it towards that one, the one that has water, until the water amount on this point is above ground. So instead of something like this, we get something like this. Pretty sick, if you ask me. But there exist certain edge cases. I think this one is one of those, even though this one is a pretty good one. I wonder, yeah. So this point right here is actually below ground. So this point doesn't have enough water. But it's like, I think it has the same amount, the water surface height is the same as the ground height. So they have the same, which means that the distance we interpolate this point is just a very, 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 very small amount. I don't even know if it's visible. Extremely small. And in this case, it's okay. But we have certain cases where it sucks. Let's see if we can get one of those to occur. This one is pretty rough, but not too rough, I don't think. I think the edge cases that, like, this happens when, so both for this point and this point, we're only getting water from the diagonal point. I wonder if that has something to do with it. Like, we're only getting water here. But let's see. On this one, we're getting water from here and here. It's still fine. This is not worst case scenario. But here we're getting a worst case scenario. 100%. I think, yes. this one. And that's what we're gonna focus on today. I think I said yesterday that I'm gonna give it today. I wanna solve it today. If we're not able to solve it today, we're gonna move on to other stuff and leave this as a future fix. Because I can't really spend more time on the water edges this time around. Gotta get some other stuff in place. And like, yeah, this looks like shit. It really does. But it doesn't happen that often, and it's like worst case. So I'm able to live with it, at least for some time. But yeah, now it's a problem of how the hell does one go about fixing this one? This point gets water from this point, and this point. It gets just it gets so much water that the height of the ground and the surface is the same, and that's when we get this issue. And I wonder if I think it would be much better if, so right now we set, it works good in some other cases, but right now we set the water fluid for a point on the edge to be equal to the maximum amount, the maximum fluid spread going into a point. In this specific case, we would probably fix this one by taking the average of all the points. Fuck, is the question as simple as that? And I want to fix it. I want to try it using the shader, so we don't have to replay anything. So instead of doing, didn't we? I think we did something similar to this one, but not really. Yeah, I think we're gonna do this. First of all, let's see. Let's remove these. Let's uncomment this one because we really want all of these values eventually. Direction, we don't care about direction anymore. Neighbor has water. Neighbor water max. But we want to skip one of these. Yo, what's up, Hercules? Good morning. Drowning in code for water. Definitely. Let's see here. Neighbor has water. Neighbor water max. Neighbor water index. Yes. We want to do this, but we want to do we want to do an additional check here. Like when we get all the neighbors, we will be getting, for this point, for instance, we will be getting this, and this. and this, but we want to skip these two. I can't never seem to, yeah, positive x, positive z, or negative x, negative z. So pretty much we want to sample all of these, but when it comes to these calculations, we only want to do it if if I is equal to j, I think. So we do it for 0. We do it for 0, 0. And then we do it for, we also do it for 1, 1, but that's okay. Yeah, that's okay for now. And then we do it for 1, 1. So something like this. Then we have position OS. Neighbor has water and point current. We don't have point current right now. We're gonna do, actually, data values 1, 1. Center position, neighbor position, data values. Here we want to do neighbor water index dot x, neighbor water index dot y. I think it's roughly this we want to do. 214. Oh yeah. Float 2. Come on. Oh yeah, we have direction here as well. Direction. So here we pretty much just want to do neighbor water max index dot x, and yeah. So this is roughly what we had previously, but this time around we add this check and we do some extra stuff here. We're just gonna get the same result now as we just have, I hope. Not really. So what's going on this time? I and j is equal. Data values y is bigger than, it should be okay. What's happening here? We're doing the interpolation the correct way. Ooh, it actually works here, but not so much here. Right. Yeah, here we're moving the full length. And we're not changing the height. This might be true for the point where we're currently at. So if we have index 1, 1 here, but this one will be false in that case. So we're not going to do this. Or it might be true. But then we get down here. Okay. So we need to check if I and J. It looks a little bit. I think we need to check. This. Not entirely sure though if. Okay, that's not the cause for it. I wonder if the problem is not Yeah, this one is actually -1, 1. That we want to fix. So we need to do. So we set this one to index. It goes between -1 and 1. So we can't really do this. Fuck, oh, we're not getting an error here. Is that true? So we would probably need to do +1 here. But the question is, do I prefer doing +1 in 2 places, or should we just do -1 here basically? Does this fix it, by the way? There we go. Yeah, there we have it. Okay, so far we haven't really changed anything, just the way we do things, but it's the same result. We can see that we don't move this one. I want to try and do I want to calculate a new water amount, basically. Average water. By the neighbors, just see what happens. So float average water amount 0. If we have a point that has 0 water, fuck do we do then? So this one, it actually has water here, but not here. It has here. I wonder if we just want to do let's just try and do average of all of them. So if this is not we want to do, we want to add an extra if here. So if the point in question has water, we want to do this inside, and here we check if it's moving diagonally, then we do this. We're gonna rename this one because I still think we want this one here. And what we're gonna do here is, yeah, we don't really care about 0 ones, so that's okay. And then we can just do average. And it would do accumulated neighbor water amount. Like this, and then here we can, inside of this one, we can calculate float, whatever. So we do this, then we have average neighbor water amount, and what I want to do then, we want to do inverse slurp from height, and here we're just going to set this one. Center position X, neighbor position X, displaced position OS from this one and this one and there, and then we do this, and this should be equal to average neighbor water amount. Maybe. So this one actually has, let's say that the height of the ground is 100, then the water amount here is 100, but we actually want to switch this water amount since it's in such a bad place. We want to switch it, the water amount there, to be equal to the average of this, and this water amount. So it's probably going to be somewhere around here, and then we do the same interpolation again. I don't know. Yeah, definitely went a little bit overboard here. That's not good. That's not good. Did I... So if we take this one for example, I don't think, did we really get that low of a water amount? It definitely seems like it. Did I... Why the hell do we interpolate all the way down there? Yeah, we're even going lower than we should. Yeah, we're definitely taking some points into account we don't want to. So I think we're taking this one into account and this one as well. But I don't... If the water value is bigger than the height value, that's when we increment this, and that's when we increment this, or accumulate this one. Oh, we're accumulating. I guess we're accumulating the ground height. So let's go with Y. See if we get some sort of improvement. Not really. I wonder if we also want to take this one's water amount into account. This one is still a very worse result. Why are we getting beneath here? Doesn't make sense, does it? Maybe. Almost all of them end up at the start point underneath. I wonder... That doesn't make much sense to me. Take the average of this, 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 and this. Okay, let's say this height and this height is the same. And let's take this one for instance. Oops, fuck. Ah, beautiful. Okay, this one. Height 71, water 72. Okay, this one has water. But this one, for instance, I guess we would like to drag this one to about here. Very interested in this one. See, this one, right? Yeah, height 100, water 100. What do we have? Water, and then we have water 93, 98, 100. did I say? 93, 98, 100. 98, 93, 100 divided by 3, we get 97. It was for this one, right? So what did we have? We get 97. Yeah, this one has 98, so we get below. That is true. What the fuck? What if we get this one into the mix? I don't know. So if we average the water amount based on that one as well. So we do... Average water amount is equal to accumulated neighbor water amount plus data values 1.y, and we divide with number of neighbors with water plus 1. I don't know. It doesn't really fix it. So what would we have here now then? So for this one we would have 93, 98, 100, 100. 93, 98, 100, 100, and we divide it by 4. Yeah, 97. Yeah, we get 97 here. Does that look like 97? Yeah, probably. Okay, so we can't just simply average them. That doesn't fix the issue. But I'm pretty sure there exists some similar way here. We just need to calculate the water amounts. So basically, we want this one to move down, but not this much. So this one traverses to this one. Do we want to go on ground height instead? 98, 95, 90. But what if, okay, if we take the difference, here we have a difference of 2, 3, 3. 2, 3, 3 divided by 3, 2.5. 2.5, so if we set this one to we do 2, 3 plus 3 divided by 4, 2. 98. Or honestly, I'm thinking, could it be as simple as what happens if we always go to the middle point? So in this case end up here, in this case end up here, and then we'll get a straight line, straight line, straight line. Yeah, that would suck as well. Works so damn good in cases like this. Probably do a simple check. If we take the neighbor with the maximum amount of water, I'm trying to remember if is all the worst artifacts we have seen when we have this case right here, i.e. when we have a water amount that is equal to ground height. Oh, this one fixes itself so nice. Because if so, we can just check that specific case and change it in some way. The question is, how do we want to change it? Do we just want to interpolate to half? Then we're gonna get something like this. That looks like shit as well. We want it to depend on its neighbors. So this point right here, what neighbors do we have? This, this. We could have it's still good. This one gets water, but it's under the ground. But it doesn't get water from its diagonal neighbor, so we don't do anything about it. Same with this one. Would doing something actually fix it? No. If we just... Yeah, it would if we would be interpolating on this one. So take this one, move here. For this one, we would... I wonder... Yo, what's up, Redibulus? What kind of game you're making? We're making a creature collecting game, but it's not about going out in the wild collecting creatures. It's more about taking care of a plot of land in such a way that creatures wants to come to you. So I don't know if you have played Chow Garden in Sonic or Viva Pinata. Much like that. Do you know scripting? I haven't done much scripting. I'm more of a programmer. Although there's really not that much of a difference, right? Would these visuals be solved by interpolating in another direction? Maybe it could. So if we interpolated this one towards this one instead. Maybe. Let's see if we can get the worst result. Here we go. Fucking hell. Here we have it. Yeah, so this one doesn't move at all. Because it's right above. So I guess that would be fixed by, if we move towards the maximum amount of water instead of only this one, then that would be, so in this case we would be moving towards here. Maybe here as well. Maybe that's better. I don't know. But I want to try it. This is a good case. So I guess... yeah, let's see. Neighbor has water true. If data value is y, neighbor water max, then we do this. So let's just comment this one out. We don't go... actually, if... we don't want to move... we don't want to move towards this point, so we don't want this one to interpolate towards this point. It's actually a neighbor, but just in the pixel space, not in the... it's actually in vertex space as well, but they don't have any connected edge, so we don't want to move that direction. So we only care about if it's a connected edge, which means I guess we can change this one to is not equal to minus j, right? So if we take this one this has negative x, -1, +1 for y. I think so. So then we always get the one with the most water, and what happens then? Do we still... here we can see this one moves this direction right now. That's not nearly as good. Yeah, what do we want to do about this one? Actually, I'm wondering... Like, I'm wondering if a hard fix like this is... So if neighbor has water, data values x is bigger than y, and then we do t average neighbor water amount. If we just do a check, that is data values 1 is equal to dot x is equal to dot y. If so, we just return 0.5, otherwise we do this inverse lerp. What kind of result would we get then? So this is a problematic point. This one is a problematic point. So what we will do, if we have problematic points, we just interpolate them to halfway between this one and this one. I wonder if it can lead to some problems we're not seeing here. It works for this case, it works for this case. I mean... Yeah, we're gonna fix the normals as well, but yeah, we get something like this. That's not good. So we actually get water going up like this. That's the point, right? So 0.5. I guess we would also like to so what if we do if data values 1.x is equal to data values 1.y, then we do something here, else we do something here. Otherwise, t is equal to 0.5 and water amount is equal to data values 1.y plus max neighbor water max divided by 2. Can we do it like this? And then we get this. What the fuck? That's not good. Yeah, the water should be equal to this one and this one, right? Nah, that's not. We want it to be equal to the biggest. Actually, we're moving it downwards. That's not good. One sec. I forgot to do. And then we want to fix this one as well. A little bit worried about this one right here. I don't think it's that much that we can do about that one though. Okay, is this a nice way to handle a special case like this? We also get, or do we? Yeah, we'll also get a little bit of a going down. We're getting a little bit of an edge there, I think. That sucks. Not a big fan of that. But I wonder why. I thought the water amount would be equal to... Yeah, so it's higher up. Okay, what if we do... Yeah, this doesn't give us... Does it? Let's say we have 190. I want to get 95, so right now we do 100 plus 90 divided by 2. Yeah, that's not... Or is it? Okay, 190, we want to get 95. We do 100 plus 90, which is 190. That's not 95. Or is it? Yeah, it is. But. Yeah, that's not what we want. We want... Okay, let's see here. This one. We want the water amount here to be equal to the height. So we don't want to do water amount. We want to do data values x. And this one, I think. Right. Yeah, we get it here, but we still get a little bit of an edge here, or do we? Now maybe we don't. Wonder if this is better. Okay, it's definitely better than this. I wanna include the other one as well. I wanna check what happens if we don't have this one. So let's do... Yeah, let's call it a flag, but we're gonna do it as a float. if test flag A is bigger than 0 and this one. Okay, so this is the original visuals by just taking the values and changing the height of the vertices making up the water. Extremely bad. This is applying the first fix, and then we have this applying the second fix. So getting the worst case scenarios, pretty much. But then again, I think rather than having this check here, like this one, I think we want to have a if, let's see, like we want to do it with an error margin. Because right now we only do it for points that has the exact same. This still looks a little bit rough, but actually, maybe it's not that bad. Let's see if it works. And here it doesn't work. What the f... And my assumption here then is, let's see. Here we might have a value that is 1 below. So let's see if we can fix that one as well. So basically what we want to do is, if we get in here, we know that this node is underwater, or I mean it's underground, the water is underground. So what we want to calculate then is float diff is equal to data values 1.x minus data values 1.y test flag A, and here we do if diff is greater than test flag A. So it's, if this one is -1, this is never going to be true in this scope, because this one is never bigger than this one. If it's 0, that means that they're exactly the same. If it's 1, yeah, and so on and so on. Oh, we don't really have a difference. So one sec, I think I screwed up somewhere here. If diff is bigger than test flag A, And that's what we want to do, and we do 1, and then we get something like this. There we go. Something like that, 0.01. Although I'm not a very big... Ooh, that is rough. Yeah, that is true. This won't really work because we have this case where we have neighbors that comes like this. Like there exist special cases. Like this one right here. So in this case we want to do it, right? But in this case we don't. Here we get a lot of water from multiple points. Hey, what's up, Minecraftian Steve E? I thought we had it, even though the solution was not the cleanest, very specific. hate this one, what the fuck. So in this case, for instance, we don't want to move this one at all. I think it's that one. 0.01. 0.01, yeah. It has to do with this one and this one. They have the same water value as this one. In this case, this, and this has the same water value. Actually, one sec. Yep. And in this case, we don't have that. This one is way lower. I don't know. I don't get why. Shouldn't it just be basically calculate the middle point of this one and this one, or the water height rather, and put it there. Yo, what's up, Fabic? So the height between these two, set the water height to that. It's going pretty good, I would say. We still have this worst case scenario to handle. I thought we had it by an extra step, but this extra step, yeah, fixes this. We can do like that. We can control the threshold for it, but it also destroys some other places where we don't want it to happen. But we're gonna get there. We're gonna get there. So for this one, if we take the water amount, and then we put, that's the water amount we interpolate between this, we get to around here maybe. And then if we do the same thing for this one, what do we get then? We get water amount, then it's there. Maybe. Do we want to take this water amount into account? I don't think so. So we want to go... We want to go... Positive, or the neighbors is positive or positive, or we want to take all neighbors, or we want to take the two neighbors. Okay, at most, if this one doesn't have water, can we assume that... Yeah, I'm gonna assume that we can only, at most, we have 3 inputs from it. If we have 3, we just take the average of the 2 ones that aren't this one and we use that to interpolate. Let's see. Let's change this one to if test flag is bigger than 0, then we calculate a new water amount and we do it by... Data values y is bigger than x, I is equal to j, else accumulated neighbor water amount else we just do this. And then we do water amount is equal to divided by number of neighbors with water. That's the water amount, and then I'm wondering, let's take this one, put it here. Let's try this. I mean, this still sucks. We see some weird thing going on with the, that's not good. Fucking hell, it does look... not really. Okay, that's true. Okay, so if we only do that, we get this result. One sec. A little bit worried about these. Why are we getting these? Although, still kind of okay. And then again we get something like this. That's not good. Almost soon there, I think. Could we do... What happens with at this point? So we move it to here. And then we change the height of this one, right? Yeah, so for this one, by taking these two, we actually get a height that is lower than this one, I think. That's not what we want to do, but can we have that as a... So, if this and... Let's see here. And then we do if that's not true. We want to check. It's not. It's this one we want to compare to. So we don't want to compare with data values 1, 1. We want to compare to this one. We don't get a change here, but we do get a change here. I wonder, do we destroy this already nice line? No, we don't. Okay, beautiful. I think that should be it. This one still, I mean, I'm not entirely sure we will get a better result with the resolution we have of the terrain and the water. So, but I mean, with this second check, instead of having worst case scenarios that looks like this, we have worst case scenarios that looks like this, which I think is an improvement, question mark. Yeah, no doubt, no doubt. I want to clean this up, make it clearer. I wonder if is this check needed anymore? I don't think so. Yeah, we're actually getting a downflow here. I think it looks good. But then again, so initial result, fix 1 result, fix 2 result. Yeah, then we want to fix the normals as well, but that should be pretty easy. Do we have any other issues? The normals are shit, but we're gonna take care of that. I wonder... it should be. Fabric looks pretty good. Thank you. I think so at least. I think so as well. Still, at certain points, we could probably improve it even a bit more. But for now, it's definitely good enough. We have the problems of the normals, but we're gonna get to that. Yo, what's up, Famil? Whatever. Much better. Okay. So in this case, let's see here. No fixes. First fix, second fix. Jagged. This one I don't think we can fix. Not right now at least, but I'm okay with that. Okay. Here we go. Okay, so when we're moving downwards or upwards, I guess downwards, we're never moving upwards. That's when most of the artifacts start appearing. First fix gives us this, and then the second fix gives us this, which is way better. Although it makes me wonder. It makes me wonder. Selection wire. What do we actually do in the second fix? We do, let's see, this one. This one is fixed by the first fix, okay? But what are we actually doing here? We're interpolating this one to here. Filling it up. Or, yeah, we move this one to the point where this water, or where the water amount in this point actually cuts through this one. But shouldn't. So we get a fix like this instead of a fix like this. Shouldn't just Okay, this one. Yeah, we would get a very bad... maybe we need both of them. I wanna try... if this one... else... or actually, I want to do... fuck, is this the solution we should go with? Inverse lerp. Let's do... I wonder if the second solution is all we need, basically. Should we do break? Yeah, or I guess we can do this. Else t is equal to 0. Okay, not 0, but 1. So right now we calculate t by, we take this, if average water amount is bigger than this one, Okay. No solution. No solution. Only the first solution. Only the second solution. I think we can just go with the only the second solution actually. So what's the difference between them? In the first solution, for this point, which doesn't have water, let's see here. For this point that doesn't have water, the second solution pretty much includes the first one. It's just a matter of how we calculate. Yeah, so it's just a matter of how we calculate the water amount that we should interpolate to. In the first solution, we just we do inverse slurp between this height and this height, and we do it based on the water amount we have here, so we end up somewhere on this line. On the new one, we calculate, we use that as this one, or we use this one. So if the average between this and this is less than this one, then we interpolate down to that one. Can we make it even better? Yeah, what about if we get the water, the average of these two, which will always result in the middle of this one. But what if we took the average of, in fact, didn't we try something similar? What if we took the average of all three? Yeah, that's better. What the fuck? So we still want it to be a bit more weighted towards its max, but do we get... I don't think I like the way this looks right here. Or actually I'm entirely fine with it. Or am I? Okay, in this case... For this point right here, we don't really get a difference because... Okay, this one actually has water, so we're not going to move that one. But then again... I wonder why this one moves so much towards... Okay, is it because this one is extremely low and we get, okay. I'm pretty sure we can adjust this even a bit more to just make it even better. But honestly, I think it looks pretty good. I think it's in a good enough state. It's in an acceptable state. So we're gonna leave it for now. And worry about other stuff. Or actually I want to clean it up first. I want to keep displace multiplier, but we're gonna remove this one. We're gonna remove this one so we can water amount. T, we can do float T. I think we can do Yo, what's up, Alex? Do we need diff anymore? No, we don't. don't even know if I want to do this cleanup. Maybe we do. This is good. Alex, this looks fucking complicated. It has been. It has been. Duan van Staden, are you more comfortable with HLSL than Shadergraph? I didn't used to be, but then I started doing shaders. Like, look at this. I'm still on Unity 21.2, so I started doing shaders that where all the functionality I wanted wasn't available in Shadergraph, and I thought that doing custom nodes just overcomplicated things, so I started doing things in HLSL instead, and that's just how I've been doing stuff for the last year, I think. So these days I think I'm more comfortable in HLSL than Shadergraph. I think so, yeah. Okay, but this looks fucking great. This, not so great. Water amount, water OS. We just use water OS here, so we might as well. Water object space, we can remove this one, and we switch this one to water OS. So average water amount, accumulated neighbors water amount, but we might be accumulating the wrong neighbors here as well. That's not good. If I is equal to j, then we have our diagonal neighbors. We don't want to use those, or do we? I don't think so. But we might get the opposite diagonal neighbors and add accumulate here. That's not good. Else if I is not equal to minus j, I think that excludes the non-diagonal neighbors. I don't even know, is this a better result or not? Let's see. Else if, can we double check this real quick? Or test flag A. So if test flag A is true, we do this either way. If it's false, this one has to be true. Or actually, we need to do bigger than 0. And there's no difference, is there? Not in this case, at least. I'm gonna leave this check anyway, because that's how I want it to work. think I want to simplify this shit as well. I don't want to split up X and Y actually. We're gonna do float 2 center values. And then we have, oh, here we actually use center values as well. Yeah, I want to simplify this as well by storing whatever data we have here in one variable. Center values, but what do I want to call it? It's neighbor water max index float 2 I want to call it like priority neighbor or something like that. Data values. Or actually, I think we can simplify it a bit more eventually. Alex, how long are you expecting to be working on this game for? Honestly, I would love, right now it feels like I would love to be working on this game for the foreseeable future or unforeseeable future. And by that I mean I definitely want to get it out to players, but even after release I want to keep working on it, making it better and better and updating and so on. But we're probably a couple of years at least away from release 1.0. Like I'm thinking something like first early access in so I think we have vertical slice of the terraforming part of the gameplay early next year. First early access at the in 1.5 years maybe. And then I don't know. Was upscale tag couple of years? Fuck yeah. Alex, I'm guessing this is a side project for you. It's a 50%, so half-time sort of thing. And I don't work with games other than this. Okay, this is beautiful. But also priority neighbor values. Yeah, we need the direction here, that's true. Neighbor water max index. Neighbor water max, neighbor has water. And then we do this. Yo, what's up? Once again, Derek. Such good work. Thank you, appreciate it. Yeah. This is a big improvement compared to this. Definitely. Alex, it amazes me the knowledge you have and ain't working full-time in the industry. Appreciate it, man. You're making me blush. Let's put it this way, like, I don't think I would like to work full-time in the game dev industry. I just don't think I would be happy unless it was on my own game. But I could definitely think about working like part-time, but or doing like contract work, but I don't know. Derek, it will probably be completely hidden with distortion and shading. Yeah, hopefully it will. Okay, so the problem we have now is you can see the normals are still fucked. But with the data we have in the shader, we should be able to alter them in such a way. We should be able to fix them. So the normals for visible points or non-edge points is 100% correct, I think. The normals for edge points, that's where we start seeing something like this. I think a better option would be to do... Ooh, can I finally remove all this? Maybe, I'm gonna leave the tessellation part. But we could probably, yeah, if we return the normal in world space, what do we have? I don't think it's visible enough. Yeah, but we can see here. So what I think we want to do is... normal in world space. What do we do? We just, yeah, we do get vertex normals, we get the world space here, that's good. We want to remap it, right? So it's currently between -1 and 1, I think. We want to remap it to 0 and 1. But I don't even know if... Like, if we want to paint it, I guess we could do... Let's take a look at that soon. Yeah, I get that. Fair enough, can kill the joy a bit. Yeah, I think so, unfortunately. I can also say this, like, if I would go into a full-time job in quote-unquote tech, I guess there would be a few different, or there would be a few areas where I would find a full-time job to be more fun, or certain areas that would be more fun full-time than game dev full-time, unless it's my game I'm working on. But okay, yeah, I just want to visualize the normals in a better way so we can actually see the difference, because right now we can only see it in this direction. And we could do it by taking... I want to check remap HLSL. Don't we have a remap node? No, we don't, because we implemented it ourselves, I think. Don't we have a remap? I was pretty sure we... never mind. All we need to do is -1 on 1. We multiply it by... Or... We add 1 and we divide by 2, right? -1 on 1, 0 on 2, 0 on 1. But I don't know if this will clear it up. Maybe. And then... Yeah, we can see it here. I would like... Or we could do... If the idea is just to visualize it, I think we could do... dot between just a point upwards and the normal in world space. Let's see what kind of result we get from this. There we go. Yeah, that's definitely not good enough. Would this work in our favor? No. Oh, yeah. What the fuck? What do I actually want to do here? I want to drag... So we get a value between 1 and -1. I want to interpolate it in such a way that we get... Am I thinking about this the wrong way? What if we do 95? Let's see, if we take a look at this one. So right here we should have normals pointing straight up. So if we do a dot product with straight up, we should be getting 1. Here we will have a normal pointing towards some side. So we will have a value that grows from or decreases from 1. So probably a value like 0.95. Yeah, we probably want to do an inverse lerp first. And I can never seem to remember. Min max. -1, 1. Dot product. So then we get a value that is between 0 and 1. Yo, what's up, Fabik? Today again. Thank you, man. Appreciate it. Making my day. Hope you're having a wonderful day as well. Keep up the good work, sir. I will do my best at least. And appreciate the lurk and the donation. Thank you very much. Okay, just need to get back into it. So I'm trying to figure out, like, what I actually want to do is I just want to highlight the subtle changes in the normal. I want to highlight sudden changes in normals. And shouldn't it be something like this? Maybe not. No. Inverse lerp between... Fuck it, let's just do it like this. Inverse lerp between 0.95 and 1. And then we have this dot product. There we go. Finally. 0.95 might be, let's go 0.9. Okay, 95 was good. Yeah, so this is pretty much what we want to get rid of, these black things here, and we just want to do it by the edge. We don't want to remove this one, but that also means, let's take a look at this one. Ooh, are we having, nah, so this one we want to fix, this one we want to fix. If we do that, we won't be having this triangle here nor here. So yeah, by fixing the edges, it's gonna be pretty, it's gonna be pretty. So the idea is, when we create the mesh, we have this edge point here. Let me just decrease this one so we can see. It gets its normal from every connected vertice, or vertex I mean. So this one, this one, this one, this one, this one, and this one. And that's how we calculate the normal. And with that information, it becomes pretty apparent that like the normal of this point is affected by this one, and this one, as well as these. And these ones are dragging it in the wrong direction. Like these 3 points doesn't actually affect or shouldn't affect the normal. So we just need to, in the water shader, fuck, yeah, one thing. If we do all of this in the water shader, we're gonna have problems with terrain patches later on. So I'm thinking about moving all of this logic to the CPU. Because remember, right now we're just working with one big terrain mesh. In the future, there's going to be multiple, and we want the communication between them to work in a good way. Unfortunately, that won't happen if, or we won't be able to do that on the shader unless we send in a hell of a lot more data to the shader, and I want to avoid that. So. Just something to keep in mind while we're doing this, but let's get it to work in with one patch first, and we can worry about the harder part later on. So what we can get here is we can get this height, this height, this height, and this height. So we basically have 4 height values, and we want to calculate a normal based on them. So I wonder, since we're distorting it, oh, it's actually this one we're working with. Since we're distorting it, we might screw up the normal as well. But we won't be able to access this normal. We're gonna have to calculate it anew. Yo, what's up, Samsmite? Do you use shader graphs for anything? Yes, I do. Like, I love shader graph. The instant feedback you get is amazing when working with parallel stuff. It's just that in this version it lacks certain features I want. If we had access to these normals, we could just do some sort of interpolation. But now we only have height. Would it be enough to do... I don't know if it would be enough to do... If we distort it and then we calculate the normal moving from this point to this point, or then we calculate the normal using these 3 points, then we calculate the normal using these 3 points, and then we interpolate between those two. So okay, we basically want to define two different planes, I think, one for each triangle. So it's going to be or would it be enough to, we calculate the vertex going to this one, we calculate the vertex going to this one, and then we do cross product between those two? Or do we need to include this one? Or actually, and that would pretty much be the most straightforward way, I think. Vertex, vertex, cross product gives us the normal. I wonder what the result would be, however. Okay, let's try. But then again... We might screw up the normal here. Yeah, we're gonna have to take more into account. But then again, yeah, at this point we want this one to affect this more. I'm thinking let's see, what do we have? Util, helper functions, calculate grid value, grid value, grid value, angle axis, generate tangent by normal. Yeah, I want to take a look at terrain shader. Approximate normal connected neighbors. Read all the values, then we do this. The problem here being we already read all of these values. I just wonder what we want to do if we don't have visible water. Do we want to put it at the maximum water? Yes, we do. Or do we? Yeah, and I don't think we can simplify it this much because delta in world space. So delta in world space is the distance from one point to another. This one changes thanks to this. Okay, so it's not as easy as that. But it should still be very easy, I think. Okay, we have 3 cases, I think. And our cases are... we want to calculate the normal for this point. if we know that it's an edge point by the fact that it gets water from at max 3 different points. If it gets from 4 or more, it's not an edge point. Yo, what's up, Robert Patterson? Yeah, we went from water simulation to milk simulation. So, given an edge point, it can be affected by one neighbor. Actually, this one is from 3 as well. This one, it can be affected by one neighbor, or 2 neighbors, or 3 neighbors. So we can see here the water from this one, the water amount here is only affected by this one, because this one doesn't have water, this one doesn't have water. Or it can be from 2 points, so this one, for instance, water, water, no water. Or 3 points, this one, water, water, water. From 1 point is probably the easiest one. Then we just calculate we have the direction of this one, and we have its tangent. So we have tangent and bitangent, tangent, binormal. We have 2 directions as well, or orthogonal, so we can just do cross product and we get the normal. And then we just set it. This one is a little bit more complicated. So here we have this direction and we have this direction. So maybe we should just take the average of them, the tangent of that one, and then we do cross product. So if we get this point, the problem, yeah, I think this one is easy, this one is easy, but this one, what do we want to do here? We pretty much have, I think we just want to do I'm trying to visualize it. If we define a triangle going from here to here to here, bam, 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 and then we calculate the normal of that triangle. Da, da, da. That's pretty much what we want to do here as well, but here we just do it. Oh, this is 3, this I mean, so this is the edge point. We take the middle point between these two, gives us a vertex. The middle point between these two gives us a vertex. So we now have 3 vertices. And fuck, would that give us this correct result? We have 3 vertices in world space. And but then again, check out this case. Edge point, edge point. After distortion we get, like, both gets distorted, so we have Complicates it. But now I'm starting to think. Could it be as simple as just making the normal point upwards? What kind of result would we get here then? Because it's the edge of the water, it's a special case. We're not going... How would that work in a downward flow? For instance here. A little bit worried about this one. Yeah, that wouldn't work. Yeah, the displacement makes it complicated. Okay, so what if okay, this is maybe the way. So when we calculate the mesh with the water amount, we don't include this one or this one or this one. We just make them equal to this one. Like, if they are below the ground level, we don't include them. If they are above, we include them. If they are below the ground level, we just set them to be equal to this one, whatever height we have here on the one we're calculating. And then we calculate the normal of this one based on that information. And then when we do the distortion, we always distort towards this one, and the normal of this one is fine. So we just interpolate. We have a normal here, we have a normal here. The closer we get to that point, the more equal to this one it is. Let's try it, it's worth it. So first of all, terrain patch, recalculate water mesh at index, We always get the water here. We want to do it's going to be a lot of ifs, that's for sure. Basically, we want to check, we want to get this value, get index wrapped. Okay, for now, let's just add an extra method here. I want to clean it up later on, but let's see here. Okay. And then we're gonna do it the unsafe way. So if patch int, oh, we actually return float here. If patch dot get data or dot terrain data dot get data, actually let's do, yeah, if get data terrain type data water is bigger than patch terrain data dot get data. Oh, we actually want to send in x wrapped, y wrapped. Let's do it like this. Otherwise, we want to do just this, I think. But 0255 water. Get water amount, we get the water. If we don't have any water, we just return whatever we're standing at. Maybe. Up, down, right, left, and upright should be 1 1, and down left -1, -1. And that's how we calculate the normal instead. Let's just see what kind of result we get from this. Jesus, already looking way better. But then again, would look extremely good if we just had it like this. But this one, when we interpolate this one, or when we interpolate it towards here, we want this one to affect the normal more than it does. So, okay, huge improvement here. It's pretty much fixed here because we're having a plain water amount. We have a little bit of a downflow here. This one doesn't really make sense. Maybe it does. This point right here still annoys me quite a big deal. I have no idea why we're getting these. Or that one. Okay. Yeah, of course. Still a tiny bit annoyed at this. But it makes sense. Thought we had that one. Oh, accumulated neighbor water amount. Yes. Okay, I'm just gonna put this one here. Note: possible improvement. Work with height instead of water when it makes sense. Hopefully I can make sense of this tomorrow. Roadpaths are nice. Appreciate it. How do they usually do that thing? Isn't it some sort of interpolation shader or something? Are we talking about normals? And how do they usually do that thing? I don't know if this is a usual scenario, maybe. Yeah, so here we take the difference between this one and this one, but this one doesn't have water, so we get a pretty low one, which means that we get this edge here. But if we would take it this height instead, then maybe, I don't know. Smoothing water edges. Like it depends. I would say that the majority of watering games are like preset models. The most easy one being just a plane, and then you don't have to worry about normals at edges. But this is a generative model, and we generate the normals the correct way during the generative phase of this normal. So we have the edge, all the normals for the grid, but then we distort it. So yeah, I think this is pretty much one of the more usual ways to do it, I would say. But then again, we could probably improve this one. Instead of yeah, we can. But I mean, this is okay, normals. Still wonder if we would like... I don't think I'm that happy with the normal we're getting on this one, honestly. Currently we're calculating the normal of this point like this is just a plane. I'm pretty sure the way we want to do it, if we're going to be... so the way we calculate the normals here in recalculate mesh data, this one. A very simplification. Like, we have simplified these calculations because we have multiple duplicated parts or factors, or what the word is for it. But what we're actually doing is we're taking current... what is it? We're taking current minus up, current minus down, do the cross product between those and add it to current minus down, current minus right. Let's see here. Let's paint it. So can we do... yeah, if we want to calculate the normal from this one, we do... we get this vector, and I think we actually do this vector, And then we do cross product between them. And then we get this vector and this one, do the cross product between them. And then we get this one and this one and do the cross product between those. And then we get this one and this one, do the cross product between those. And then we get this one and this one, do the cross product between those. And finally, I think we get this. No, not this, that one. So basically, we calculate this normal, this normal, this normal, this normal, this normal, this normal. Yeah, that's pretty much how I want to put it. Let's see. So we split this one up into triangles or planes like this. So we have 1, 2, 3, 4, 5, 6 planes. We calculate the normals for all of those planes, and then we average the normal for this point. So this point has a normal that is equal to the average of all of these planes normal. And that's nice, gives good results. Oops. But previously we always know that all of these points will exist, or all of these planes, but when it comes to water we might actually get a plane that looks like or let's see here. Thinking about this the correct way. We might get this, I think, or not this, but let's say yeah, we might get this one, I think. So then we just want to do it on 2 planes, and we might get this. Then we just want to do it on 1 plane, and then we might actually get this one. Yeah, so we could actually de-simplify this one, do it in iterations instead. Calculate one direction, cross product, add to accumulated normal, do another one, add to accumulated, and so on and so on. That would probably give the best result. I think that would result in a more skewed normal here. So a normal that is pointing more in this direction, I think. So we wouldn't get these white edges here. But then again... Yeah, my biggest question would be, so this one is pretty simple. Average the normal from 2 planes. Just use the normal from 1 plane. Can we just use this normal here in this case? Yeah. Or is it better to calculate random tangent or set the tangent to world? I don't know. This one might be a little bit different, but yeah, okay, let's see. So when we get to water, what I want to do instead is get water amount, up, down, right, left, up, right, down, left. Yeah, we want to be careful with the first normal as well. So, but yeah, we can handle that soon. 0, 1. Up, down. I want to make sure the order is correct here. So we're gonna go up, then we're gonna go up right, then we're gonna go right, and then we don't have a down right, we just have a down, but then we have a down left, and then we have a left, but then something like this. 4 and I is equal to 0, I is less than offsets dot length, I plus plus, and then we do, okay, that's true, we have J as well. Okay, let's go with X, Y. We pretty much want to do this. We want to compare stuff and things like that. But we can also do vector 3 dot up. So if we have water that is below the terrain, we just give it a, what fuck, is this what I want to do? No, it's not. Definitely not. We're gonna do this. Vector 3. T-Rex, thank you for the follow, appreciate it. Normal. And then we do bool. Normal instantiated. False. And then we start looping through these. So we always have current water and current height. And then we do I'm probably gonna have to recreate water is equal to water float water A is equal to this is get water amount yeah, I don't like this. So we're gonna do bool out float water amount. Can we do it like this? If water is above ground, it's an int. Let's do this then. If water is above ground, set water amount is equal to this one and return true. Otherwise, can we just return false, or will it complain about this one being not set? So water amount is equal to 0.0. The problem being we can probably do it like this: out vector 3, and then we name these point A, point B, water point, new vector 3, and here we do position os.x, position os.z. Oh yeah. Patch, and then we also want this one taken index X wrapped, Y wrapped. Definitely want to clean this up eventually. Okay, so if water is bigger than ground, for this one we return a water point which has the X and Z position of the point in object space, and it has the water as Y. Otherwise we don't give a damn, so let's just return 0. Okay, point A, point B, because what we want to do then is if get water amount, get water point, so we want to do if get water point. First of all, we're going to do this. Vector2 int offset A is equal to offsets I, but we want to do offsets I, and then we want to do vector2 int offset B is equal to offsets I plus 1 modulus length. Basically want to loop through it. So first we do it by up and upright, then we do it upright right, then we do it right down, then we do it down, down left, and then we do down left, left, and then we do left up. So get water point. So if get water point X, Y, offset A dot X, offset A dot Y, and we want to send in point A. And get water point X, Y, offset B, out point B. So if both of these points are above ground, then we can use them to calculate a normal, and we pretty much want to do it by going, I guess, vector 3 let's just call it n, vector 3 dot cross between vector 3 point current is equal to what is it? I never seem to be able to remember the order. We want to have a point there. Fuck, is it? point A minus point current. Maybe we get the opposite, but yeah, point B minus point current. And that's our new normal for that triangle, or whatever it is. And then we want to check if normal instantiated, we do something else, we do something else. So here we just, so if it isn't instantiated, we set normal to be equal to n, and we set this one to be equal to true. If it's already instantiated, then we want to do I just want to make sure interpolate between two normals unity. Normal angles. Beautiful. But I wonder if we can just rely on this one. I'm not sure. Wonder if this will work. Normalized, otherwise that's not at all how we want to write it. I don't know. Maybe. So calculate water normal. Recalculate mesh data. Index. Here I guess we just want to send in position. Is this current? Yeah. Correct. Normal we already have. So we remove that one. Tangent, yeah, fuck, we might want to calculate the tangent as well. We need to interpolate this one as well, I think. Something like this. It's a mess, but let's see what we get. Could it be? Could it be? Yo, what's up, Derek? We have improved the normals somewhat. We want to improve the normals a tiny bit more before we start doing calculations with it. Point current, yeah, this one, yeah, yep. Get water point. Yeah, we have a little bit of a problem here. This one just takes current water, and current water is a integer. What do we do? Here, get water data, and here we remap this one. Could it be this remap that is the problem? not so sure. Maybe. Ooh. Yes. Okay, I think we got it. And the problem we're having here. Yeah, this one only gets its normal from this one. So this one has a normal of... Yeah, we need to fix that case as well. So it's this case. But how does it look for this one? It should get it normal from this, this, and this. Oh, that's fucking beautiful. That's exactly the normal we want to see there, I think. Yeah, I'm pretty sure. Yeah, it is. This one is beautiful. Okay, so we only have one problem left with normals. The normals that only has one neighbor of water are still not being generated correctly, but every other normal is perfect. So perfect and perfect, but good. I mean, it's rough because our we have low resolution meshes, so this is probably the best we're gonna get, but I think this is great. So yeah, just need to fix these, and then we can finally, I think, now we still have some tasks left. I still want to do these things, but we can probably manage them tomorrow. So looking real good to start doing water shader on Monday. Very nice. But now I have to go. But great progress today. Fixed the last artifact, edge artifact, improved the normal generation. I'm happy. So thank you so much for watching, everybody. Have a great rest of the day. Peace.